Question B. Use an appropriate substitution to show that this integral equals that answer. Okay, so this is a mean one. They haven't told us what substitution to use. We know we're supposed to be integrating by substitution. If you attempted a substitution of u equals 1 minus x squared, I think you'd get in a bit of a nasty tangle there. Okay, it's not going to work out particularly nicely because of the x squared sitting on the top. That won't disappear nicely. So it's a better plan to try and use a trig substitution. And the clue in the answer is that pi. Okay, that's not going to appear without any trig being involved, really. So we can look at this and think, well, what could I replace x with? 1 minus something squared. Now, you might remember your trig formula. 1 minus sine squared equals cos squared, or even 1 minus cos squared equals sine squared. It doesn't really matter which one you choose. I could let x be sine u, or I could actually let x be cos u. It would work either way perfectly well. I'll choose sine. So I'm going to say let x equal sine u. Therefore, my square root of 1 minus x squared turns into square root of 1 minus sine squared u, and 1 minus sine squared is cos squared, and then square root of a cos squared is cos. So the bottom of that is going to just need to be replaced with cos u. The top is x squared, so that gets replaced with sine squared. Okay. The other thing we must do, which I normally do immediately, is to differentiate the substitution statement. So we know how to change dx. So differentiating sine gives us cos, and we need to times the du up to say that dx is cos u du. And lastly, I'm going to change the limits. You may not have to, but I normally do. So when x is a half, we can say that a half is equal to sine u. And if you type onto your calculator in radians, shift sine of a half, you're going to get pi by 6. That's your new top limit. And when x is 0, and you type into your calculator shift sine 0, you're just going to get 0. So the bottom limit doesn't change. So all of that preparatory work lets us turn this integration into sine squared u, that's the x squared, over cos u, that's the root term that I tidied up, times by cos u du, that's the dx turning into the cos u du, and your limits are now pi by 6 and 0. So the cos u on the bottom cancels out with the cos u on the top, and we end up with the integral of sine squared u du. So now we've got to remember, there's more to it, we've got to remember that the only way to integrate a square of sine or cos is to use a cos double angle. So I want to use cos of 2a is, now I want the one with sine squared, so that's 1 minus 2 sine squared a. It is worth learning those if you can. If I rearrange that, I get 1 minus cos 2a and divide through by 2 because I just want a single sine squared. And I'm going to write those as two separate terms because they'll integrate as two separate terms. So my integration becomes a half minus cos 2u over 2 integrating du. And now finally we're at the stage where we can integrate. Okay, so that's going to then become a number integrating du is going to be a u term. Cos integrating will turn into sine. the angle stays the same, and you divide by the differential of the angle. You've already got a 2 on the bottom, so that's now over 4. Okay, and then we can put our limits in. So we're going to get 1/2 times pi by 6 minus sine of 2 pi by 6, that's the 2u bit, over 4, minus 1/2 times 0 minus sine of 2 times 0 all over 4. Well, half of 0 is 0 and sine of 0 is 0, so those terms both disappear. Okay, and then we've got 1/2 of pi by 6 is pi by 12. What we need, yeah, that's right. And then hopefully the other term will work as well. So in radians, inverse sine of 2 pi over 6. Try again. No, not inverse sine, just sine of 2 pi over 6. There's the root 3 over 2. Over 4. That's the over 8. And we know that's right because the answer was given.